Okay, so this video is talk about one other question is a rectangle is bound by x-axis and y equal to square root of 25 minus x squared. What are the length and width should the rectangle have on the area as a maximum? So first of all, let's recognize that this part here, let's recognize that this part is y equal to square root 25 minus x squared. Now, this is a very important equation. I always tell people, so let's always understand this equation. How do I understand it? You can square both sides, and you're going to see that it's actually some question that you're familiar with. Move the x squared to the other side. This just means a circle equation, right? Now, when they have the thing about circle equation is actually a plus minus here. But the problem is they only give you plus. That means there's only top part of semicircles. So this is going to be a top part of semicircle. So x-axis I use red because they also say it's bounded by x-axis, which is red here. This is x-axis. Also the graph is going to be 5 and 5 and 5. So it's going to have something like this. Now, what's the biggest rectangle you can fit in this semicircle? Well, a rectangle is based, they say base bounded by x-axis. So the base has to use x-axis. So I can have as y as this part to build up a rectangle like this, or I can have this part, right? Or I can have this part, right? So really depends which is the best size. And then you say, okay, well, we don't know, but we're gonna draw a rectangle in here that fits the situations. So we're gonna draw a hypothetical rectangle here. And they just disappear, but gonna draw this rectangle here. And we don't know what is the length of the x and y. Now here's the hard part, is recognize something. Now the equation doesn't have to be a semicircle, could be, could be ellipse, could be a parabola, could be all other shapes the graph. And then you just have to find out the area rectangle. In this case, that there is an area rectangle here. Now, obviously, it's something what you have to see first. First, the area rectangle is composed of this x, and this is y. Well, obviously, we know what y is. We don't know what x is. Y is going to be represented by the function. So what will be area of this rectangle? Now, the people's going to say, what?
Probably 2xy.
Yes, it's going to be 2xy. Now, the problem people forget about the 2 because they are two sides of the x. Okay, so there's x and there's x. So pay attention that there's both sides has x. So the area is going to be 2xy. So then area is equal to 2x and y is equal to 25 minus x squared. Now, on your homework, it's probably going to be a lot easier rather than semicircle, but I give you a semicircle equation just to see the hardest one. So when you're doing your homework, it's going to feel a lot easier. So then I'm going to take a derivative. In this case, we cannot drop the absolute value sign because the absolute value sign is relevant, unlike the distance one. So I'm going to take a derivative of this. It's going to be 2 times 25 minus x squared is a product rule and chain rule. So I'm going to do derivative of 2x first. I got 2. And I'm going to have 1/2 power plus 2x times 1/2 times 25 minus x squared to the negative 1/2 times negative 2x. Again, you had to factor out the most negative. So this one's negative half. This 2 is going to cancel out. I'm going to use a different color. Maybe that'll help you. The 2 is going to cancel out here. And I'm going to factor out negative half. And I'm going to factor out 2. So what do I have? Well, I have 25 minus x squared for the first one, because that's going to be 1/2 minus negative 1/2. And right here is going to be minus, if I take out 2, it's going to be minus x squared. So again, is equal to 2 over 25 minus x squared, 2x squared, sorry, over 25 minus x squared to the negative 1/2. So you can set bottom equal to 0, but bottom equal to 0, just x squared minus 25 equal to 0, x equal to plus minus 5. Obviously, you cannot, it's not a physical restriction because you cannot form a rectangle there. So this one is not part of the solutions. So you're going to set 25 minus 2x squared. If I take a derivative of that, or if I set it equal to 0, so that's equal to 25 equal to 2x squared. X squared equal to square root of 25 over 2, which is 5 over square root 2, plus minus. So if I want to find out the length of the bottom is going to be 10. So this one is equal to 5 over square root 2, and this one is equal to 5 over square root 2. So it's going to be 10 over square root 2 times, you had to plug in, so y is equal to 25 minus square root 25 over 2 squared. So that's equal to 25 minus 25 over 2, which is equal to 25 over 2. So that's equal to 5 over square root 2. And if you want to know the area is going to be 2 times that, which is, this is already 2. So it'll be 50 over 2, which is 25. So that is the area. Area is 25. Any questions? So each direction you need to expand about 5 square root 2. So it'd be both direction, it'd be 10 square root 2 times, if I plug in square root 25 over 2 into original function, I'm going to get also square root 25 over 2, which is, if you multiply those two together, my total area is going to be 25. But they ask what's the width and length. Width is going to be 10 to square root 2 times 5 to square root 2. Do I have to rationalize it? Not really.
Where did you get the 5 over the square root of 2? Like, was that the y? Or?
Yeah, this is right here. Is the second derivative equal to 0? First derivative equal to 0. And that's equal to plus minus 5 over square root 2.
I mean, wouldn't that be x equals 0 though?
Yeah, that's x equal to 0.
Yeah, so what did we get for y?
You had to plug. Oh, when you cannot see it. Oh, I don't know what happened. Do you see it? No.
No, we just see the answer. There we go. So I'm assuming at like 25 over 2.
Yep.
Oh, never mind.
You take this, plug it back in the original equation.
Never mind.
Now on your thing, it might be a parabola, it might be a something. Sometimes gonna be a different range of questions. Just pretty much is area, like a biggest rectangle inside the curve, and that's what usually question will word it. The only way that you go do it, just figure out what's going on. Now this one's the hardest one because this one's semicircle, so that involve a chain rule and factor out the most negative. In other cases, you're not gonna have something like this.